Hello, I am Mudina, and welcome back to Satisfactory. This is episode 29 of the load balance playthrough, and today I'm going to tackle pressure conversion cubes. I have all the alternate recipes. I'm going to utilize the cast screw, silicon circuit board, and the radio control system alt recipes. These are a great combination of recipes that are a bit more efficient than the default ones. I already have all of the fused modular frames I'll need for this. If you'd like to see that video, the link will be in the description. The larger majority of this video will be making the 30 radio control units I'll need. I'm also going to add some drones to the Dune Desert factory, since I'll be needing to send all these parts out for my space elevator parts. I'll be using these nodes here. Let me briefly explain what's going to be happening. So I know this looks like a lot, but I promise it's really not too complicated. The main two things that we're doing is creating the radio control units and then combining those with a bunch of the fused modular frames that we made in the last video. So as you can see up at the top, there's a slight color difference. The aluminum ingots, the rubber, and the fused modular frames are already done. I'm going to go ahead and turn the ingots into casings and then transport those by train out to the desert. As far as the nodes in the desert go, I'm going to need rock quartz, copper ore, and iron ore. The iron ore is going to all get used to turn into reinforced iron plates. I need the copper to make mainly copper sheets, and the other bit is going to be used to turn into wire and then cable. The cable, the reinforced iron plates, and quartz crystal will then get combined into manufacturers making crystal oscillators. To make the radio control units, I need those crystal oscillators, circuit boards, which I need the copper sheets and silica for, and then I'll be combining that with the rubber and the casings that are coming from the train. And then I just need 15 assemblers to combine the fused modular frames and the radio control units, and I'll have 15 pressure conversion cubes. Here we are in the Dune Desert with our existing heavy modular frame and fused modular frame factory. Today we're going to add 3 more platforms to the top, so let's go through the blueprints. To start things off, I'll need 8 sets of the 3 smelter blueprint, along with 6 sets of the 5 smelter blueprint. Moving on to constructors, I'll need 4 sets of 3 constructors, 4 sets of 4 constructors, and 5 sets of the 5 constructors blueprint. I'll also need 4 sets of the 5 blueprint combo for assemblers, along with 4 sets of the 2 assemblers blueprint. To finish things off, I'll need 9 of each of these manufacturer blueprints to make the crystal oscillators and radio control units. And just underneath these towers, I've got the base for the 2 quartz nodes, the copper node that I'm going to need, and then I'm just going to need to use 1 more iron node up front. So let me build up the towers, and then we can throw these blueprints in them. Here we are at the very edge of the world with our 2 quartz nodes. So let's start with these ones, since they're the quickest and smallest towers. So I've already labeled them. I've got the miners in place. This one's going to do 132. That one's going to do 300. So this one is going to do our silica. That one's going to do the quartz crystal. With the silica, I need 6 constructors. So this is real easy. We just need one of these 3 constructor blueprints on each floor. There we go, make sure it's all even. And now we just need to switch to the 4 constructor blueprint and do the same thing. Now these barely fit in here, and so I am going to have to switch around the merger and splitter. But that's okay. I'll come back through and repaint everything the correct colors so it all looks nice, but for now we're just going to get the machines and belts in place. As far as the recipes go, we can go ahead and select silica, and we can go ahead and just do the long math here. So 220 is the total silica I need. We're going to use 6 machines, and then we're going to divide that by the default rate of 37.5 and then multiply by 100 for the percentage. And there we go. So that's about as accurate as I can make it, and that gives us a nice even 22. Whereas if I had just done 220 divided by 6, it's ever so slightly different. So that's the reason I just do the long math out of habit now. With The quartz crystal, it's nice and easy. It's 8 machines, all at 100%. Well, like I said, I'm going to need to swap around the splitters and mergers right here at the end. So we're just going to swing these around because I've got that open space here. I'm going to place 2 floor holes right here. And we're just going to split this down below. So since 300 is coming out of the miner and we need to split it across the 2 floors, we just need 150 on each of these belts. So mark 3. Gonna go ahead and just throw down a splitter here. So mark 4 out of there. Close enough. Go there, and then from here, it's clipping ever so slightly into the wall, but I'm just gonna pretend that's not there. So up here, we're going to grab mark 3 there, and then we can go ahead and extend this to top floor. There we go. So if 150 is coming into here, that means we're splitting it in half, 75 and 75, and that's all the machines being fed. For the silica, I'm just going to go ahead and plop down floor hole here and floor hole here. And then we'll just go ahead and split it down here. Since this is 132 coming out of the miner, we just need 2, mark 1. Alright, back with more iron plates. So now I can run this to the top floor. So just need mark 1. Go ahead and throw that in right there. And then we can just plug them into each of the floors. Like so. And that's pretty simple. So I'll work out how to combine them and then send them over here. Since this is the last of the projects to go on out here, which is good. I'm pretty much running out of room. I am going to add a wall to the back, and then I'll feed that through there, and I'll make sure to show that off before we get it started. But let's work on the next tower. So we've got this copper tower. We need a couple things out of here, and I went ahead and just ran the nitrogen straight through there, so thankfully didn't have to adjust it too much to get that to work. Alright, let's place some machines. So normally I start at the top, but I already know which way each floor is going to be facing, so I'm going to start at the bottom. Also because I think I've just realized that this isn't tall enough, so we're going to see how far I can go and see how many floors I'm missing. Alternatively, I could have made this a little bit wider, and I would have been able to fit 2 of these blueprints, so instead of using 4 floors, it only used 2, which I think would be the smart decision. But I'm not going to make that decision. And the reason is optics. Just to put it plain and simple, I actually kind of want a tall tower because it's kind of it's off to the side and it's not in front of this whole platform, so I just think it'll look cool. It adds some color since almost all of the towers are built on iron nodes. They're all the same gray color, which I really like being able to tell what they're built on. It makes for a very kind of boring color scheme, so having one copper colored tower in the background I think is just going to look cool. So I am definitely quite a few floors short, but after the copper ingots, I'm going to make all the copper sheets. So I just want to get these centered, so I've got 1.5 foundations in the front and the back to do any of the belt work. And we just need 4 floors of 6 machines for all the copper sheets. And yeah, I definitely did not get the height right on this one. So I'm short 1 floor for the copper sheets, and then I'm going to need, I think, about 5 more floors. I don't know what I was thinking exactly. I guess I just stopped short and thought I was done. So let me add some more floors and we'll continue with the build. And we're back. So I added a couple more floors, and I may or may not have just kind of zoned out and built the rest of the tower. So let me explain what I did. So I think I got up to this height. So I needed 1 more floor of the constructors. So we just added 2 more of those blueprints. And then I went ahead and added the assemblers. So I needed 8 in total. So we've got 2 floors of 4 making the circuit boards. So these are all clocked to 100%. And above that, we have 2 floors that have the 5 constructor combo blueprints that are making wire. And the last floor is making cable using the same 5 constructor blueprint. So these are ever so slightly underclocked, but thankfully not too crazy of numbers to work with. So let's go back down to the bottom and let me show you kind of how the belting worked. So we did have a little bit of load balancing to do. For this project, I needed 580 copper ingots, which is just a shame that I didn't need 20 more because I'm sure all the numbers would have worked out a little bit nicer. Instead, they all got underclocked to 96 2/3%, so I got 29 instead of the 30 out of each machine, which then in turn ended up making for some interesting belt work. So the easiest way to do this was to bring up the floor below. So I've got these 5 and then the 5 below. So that would be 10 machines making 29 each. So in total in this merger, we've got 290. Okay, just had to make some minor edits real quick. So I realized I didn't do the split belt trick at first. So the way this is working is we've got the 290 coming into the smart splitter. From there, I am sending it to the left and to the center with the overflow going to the right. So since this is very not close to being full, since that's 480 and we've only got 290 on here, I've got to use the split belt trick to make sure that I've got enough going both ways. The reason for it is if you laid out just a normal belt and you put 290 on a 480 belt, you're going to see huge gaps, right? For a Mark 1 belt to be full, it needs an item on there. I believe the way it works out is every second. I think it moves at 1 meter a second. And so if one of those gaps show up at one of those points, there's just going to be a gap on this belt. And then it's not going to have the full 60 that I'm counting on for the rest of the split to work. So that's why I have a Mark III, because this will be able to more quickly grab it. It will do the start and stop kind of stuttering belt effect. And I don't love that, but it is an effective way to make sure that this belt will end up being full. If I notice that it still ends up with gaps, I'll just make this one and this one Mark IV, because then it should be able to make up for it. So we've got 60 going here, 120 going here, because the slowest belt is what's going to limit the speed. From the 60, I'm going to split it in half. So here's 30 and here's 30, merging back. So that leaves us with 30 and then 120. So I've got 150 here, leaving me with 140 on this side, which is the amount that I need for the wire. Going up to the next floors, I just have this one coming up to here. So these 2 floors are another 10, making 290, plus the 150 that we split off from down below. So this gives us the 440, which is the amount that I need to make all the copper sheets. The copper sheets are split across 4 floors. So this is how I did it. So we've got that 440 coming up here. This half is going to skip a floor, go up to here, and then get split again. Whereas this bit is going here, half of it stays on this floor, and then this half goes into this floor. So this is essentially just splitting it in 4 ways. Above the copper sheets, we have the assemblers making the circuit boards. So this is where all of the copper sheets are going. And we'll be bringing in the silica from right around the corner. We're just going to have that go in through the building and then out and plug into this factory. So I'll have to do that little bit of bus work later. But this is only split across 2 floors, so it's pretty easy. So we've got the silica is just going to run up this corner, get plugged into a splitter. Half goes to this floor, the other half comes up to this floor, and same with all the copper sheets. And the top 3 floors are basically getting our cable done. The 140 copper ingots that I split off is coming up to here, and we're going to split it between this floor and the next floor, and that will make all the wire. And since wire is a 2-to-1 ratio, we only need 1 floor of 5 to finish it all off and turn that wire into cable. Now there's one other tower that I already did, and let me show that off. So here we are back kind of in the midst of all the other towers. I've already got this bus set up, so we've got the 600 aluminum casing and 300 rubber that I'll need for the radio control systems are already being sent over there, and they're just being sunk just so I could set up those lines and make sure that the throughput was good. And then I decided we'll just add on the reinforced iron plates to here. And I've done this sort of a thing a whole bunch of times, so I didn't think it was too important to show off. I still have a little bit of belt work to do that I clearly forgot. The 2 sets of 5 smelters, and then from there it's pretty simple. And this is the really easy load balancing that I did on this side. So if we come up to the top floors, so for the reinforced iron plate, the way it breaks down is you need 30 iron plates, 60 screws. But the way it breaks down as far as ingots go, you'll need 3/4 of your iron ingots to go to iron plates and 1/4 to go to the screws. So to do that, since I've got it split in half already, I just split one of these into half, merge it with the other one. So now I've got 1/4 here, 3/4 here. So 1/4 is going to feed all of the screws. The 3/4 is going to feed all of the iron plates. And then we just have 1 floor of 5 assemblers to make all of the reinforced iron plates. And I forgot a belt. So since we only need 25 a minute, we just need Mark 1. And then we're going to send that down to the bus. And, well, this is why I set up these early. There's clearly something wrong with the amount of rubber. And it should not have a gap. So, a little minor mystery for me to go solve before we work on the next part. So I'm going to get all the materials. I am going to solve my little rubber problem. And then we're going to add 2 rows of manufacturers, and the very top one will finish it off with the assemblers making the pressure conversion cubes. We are back to having a nice steady supply of rubber and still the aluminum casings. So hopefully that problem has been solved and we can get back to building this factory. Alright, let's just paint the middle. And if you're wondering what the issue was, it was absolutely just a wrong speed belt. Make the radio control unit for yellow down the middle. And then the pressure conversion cubes are, I think, black and orange. I don't know, we'll make it orange for now. Maybe I'll change it to black. The one other issue I ran into while doing this, I started to see my power start to fluctuate, and it was driving me absolutely insane. Trying to figure out what in the world I did wrong somewhere. And turns out it was an issue about 60, 70 hours in the making, I think. When I set up my turbo motor plant just so long ago, I set everything up, but then I forgot. Quick pause in the story. I'm just doing all of the manufacturers, and the way I'm going to be doing this is they're each going to get their own 4 foundation block. So back to my huge story that almost crashed my world here. It's being a bit dramatic, but it's what it felt like anyways. So I had set up the turbo motors, everything like normal, but what I had forgotten was to change the setting on the smart splitter for the overflow for the sink. It's the very last item. It was the only one I've forgotten to do that for. And all of a sudden, things started shutting down, and I just couldn't quite figure out why. And it took a while because I really didn't think there was an issue with the swamp, so I didn't go out there. But turns out that once that backed up, it's the one train that is essentially the equivalent of a sushi belt, where it's picking up 3 different items, and then splitting them using smart splitters. And so obviously once the turbo motors eventually backed up, mind you, I'm only making 2 a minute, so it took a very long time to completely back up 3 industrial storage containers and a drone port and the belt connecting it all the way back to the train, which also has another buffer. So it took probably closer to 80 hours in the making for this issue to finally show up. So pretty funny. Everything started backing up and then eventually shutting down. And so by the time I finally realized that, because I don't go back to my storage facility, so I didn't notice that those belts were backing up or anything. So it took a long time for that to show up. But that's why I like having the 2 power grids, so that if I do start seeing fluctuations, it's usually pretty obvious that there is something wrong somewhere. So it did take probably a good hour to clear everything out. The one nice thing is that meant that none of my turbo motors had been sinking, and so when I did finally clear it all out and sunk all of that backed up material, got a whole bunch more coupon points, which is nice. Alright, so there's the first 10. Now we just need to do these 8. And for the assemblers, I need 15, so that's going to be 3 sets of 5. So to line these up, it's pretty easy. I just want to line up the stairs with the splitter, which I usually try to do on the seam of a foundation. And then just make sure that the machines are even. And we'll just have to redo power for all of these, but that's okay. Probably should have built it in, but these amounts of machines don't actually feel so bad to manually place. Now that I've got plenty of space up here, we're just going to spread these out a little bit. Alright, and there we go. So, belting this up, it's going to be fairly easy. To finish this blueprint, we've got to connect these. It's the only part that's missing, minus all the mergers in the back. If you're curious how I put together any of these blueprints, there should be a link in the description to another playlist where I go through all my different blueprints. And I have them all available on a Google Drive. So since I've got the 3 groups, it's going to be pretty easy to load balance. So why don't we just go ahead and we'll just add 2 splitters here. We'll just bring up the inputs from below. But we're able to use Mark 1 belts for everything because this is requiring a whole 15 of the fused modular frames and I believe 30 radio control units. So that floor is real simple. This floor is also going to be really simple. I'm going to go ahead and use my blueprint of 4 splitters stacked. You obviously don't need to, you can just easily click it 4 times, but I really kind of like using the blueprint. And this is where I realized I placed a whole bunch of them 1 meter off. So I want all of these to be on either a half or the split of a foundation. It'll just make everything a lot easier so that I can place this one right on the edge of these. So let me go ahead and fix all of these manufacturers. There we go. That's what I get for trying to tell an unrelated story at the same time. So those 2 are going to get belted up together. These 2 are going to get belted up. And to connect those 2, we'll get one there. And I need some more cable. So that will split everything for those 4. So to get it to all 8, we're going to place this one here. Perfect. And then do the same thing on this side. So those 2 there, this one 1 notch. And there we go. I'm using the radio control system, so we're using all 4 inputs. The aluminum casing is the only one that's going to need to be Mark 2 straight into the machine. The rest of them are all going to be fine with Mark 1. So let's just go ahead and make that one the bottom one. I guess I should just be connecting this at the same time. I can make the rest of these connections Mark 1. I know some people really don't like manufacturers, especially having to deal with all 4 of the inputs, but this right here is actually why I really like dealing with the manufacturers. Is this just looks cool to me, and load balancing it is in a weird way fun. So one thing I did forget to do was underclock it, so let's do that real quick. And thankfully this isn't going to be one of those crazy decimal points or repeating numbers. So we need 30, we're going to use 8 machines, so 3 3/4 a piece. Nice and easy. Okay, and thankfully I didn't do all that work for nothing. This is still the only one that needs Mark 2 straight into the machine. The rest of them are Mark 1. Let's go ahead and deal with that one, since I know the bottom one I'm going to do aluminum. So that was, I think, 75? 75. Alright, so 75 and 75. So we've got 150 going into these. Let's just do that for all of them. So that means 300 on these belts. And you know what? This is the first one where we needed 2. So let's just go ahead and add that for all 3. And we can add that on the same side here. Make my life a little bit easier. Okay, so that was 300, so we've got the Mark IV. And there we go. So I'm going to set this up so that the one that needs the most is on the bottom and kind of work my way up. So next one we'll do is rubber. So Mark 1 was fine there, but now we've got 75 on this belt. So 150 from here. And that's where we'll plug in the 300. Next one is circuit boards, and we can actually do the crystal oscillators at the same time because they're basically both just Mark 1 belts all the way back. So I am making 100 circuit boards for this. So we need a Mark 2 to plug into there. But after that, everything is Mark 1. Alright, and that is the radio control system. So now let's grab this blueprint and let's do the same thing for these ones. And again, I'm going to realize that these are all like 1 meter off. Let me fix that. Alright, so now we can do the last bit of belt work up here. Alright, so every 2 manufacturer is plugged up together, and the reason for that is now I've got 5 of these stacks to work with. So I'm basically just going to do a 5-way split like I've done up there using these. Thankfully I've got plenty of room to work with. Alright, so we're going to start over here. So this one is going to deal with these 3. And then we've got one in the very center that needs to kind of feed both halves, right? So if that one's in the center, that one's going to be right on the line. And then this one on this side is going to feed these 2 and have the part that's going to loop back. So I'm going to spin this sideways just to make things a little bit more convenient. Definitely didn't grab enough cable. And we're back. So I think we've got pretty much all of the splitter stacks done. Now what I need is a stack of mergers, which I don't think I have a blueprint for, and that's okay. So we're just going to place this one right here. 4. Alright, let's take a look at the recipe. So for the crystal oscillators, we are just using the default recipe, which I almost forgot. Only need 3. So we can actually go through and just delete the very top of all of this. There we go. Everything got a little bit shorter. Thankfully, all the amounts that we're working with are real small. So everything's going to come in on one belt, so we can split all of this the same way. And for the first few belts, we can use Mark 1. So after this autosave, I'm just going to go ahead and plug up everything. For this next step, we're also able to use Mark 1. And this is where it loops back. And then for these 3 sets of pairs, we're going to go ahead and connect it to this merger. So we'll go ahead and grab our stackable. It's going to go right there. And now to connect both of these halves to that middle splitter, so let's make sure we've got all the right belts. So for the quartz crystal, we need 18, so 18 and 18, that's going to be 36. So on these belts is 36, which means on this, we're going to need 108. So definitely going to be Mark II for this one. Means for the cable, that's probably going to be the same. So 14 and 14, so 28 here. 3 ways though. 84, so definitely more than 60. So we're going to go ahead and use Mark II for the second one. But in total, there's only 10 crystal oscillators, so we definitely only need Mark I. Now for this part, we need to make sure we've got enough for that as well. So for that middle one, it's 168. So that's the Mark III. And there's really no way that that's going to be more than 480. So that's Mark III. This is Mark I. Now I just need to plug in the 3 different inputs right into those mergers. Alright, so let's go ahead and just fast forward a few hours. After, just a few more hours, we've got a back to the factory. I've got walls all the way around. It's finally all enclosed. So let's take a look. So we've got the 2 quartz nodes, and if we take a look, we just did some overly complicated stack a merger on top of another merger to bring this floor and the other floor together, send it over to the other tower. Silica was nice and simple, so same sort of thing. We just have a second merger, we bring that up, and then now it's on the same level. We can just send that right out. Let's go inside. So, like I mentioned, I did label these just to make my life a little bit easier. I've got 180 quartz crystal, 220 silica. The silica is headed right on out and into this factory that's making the circuit boards. So we've got this all set up like I already showed off. And here are the finished products. So we've got circuit boards on the green line, cable on the black. And even though they're color coordinated, I did just go ahead and add the same signs over here just to make my life a little bit easier. When I'm ready, since this is all on the same power switch, I'm doing the same thing as the fused modular frames. I am just going to connect this whole floor and it'll get all of that turned on. But we're going to do it in 2 stages like I've done with a bunch of other things. I need the reinforced iron plates to make it a good ways over here before I turn everything else on. So I've got the rubber and the aluminum casings just being sunk here. I'm just going to delete this, plug them up right there. The heavy modular frames are sinking. This is basically just to, well, let me show you actually. So, as you can see, they're not backed up. So I've got 4 drone ports over here. So this one right here is the only one with the drone. This one is going to be doing our batteries. And then, okay, so I did. So everything's pretty much abbreviated because the names are just so long. So fused modular frames and the pressure conversion cubes is going to the thermal propulsion rockets. So this right here, I think I need 10 of one of them and 5 of the other. So one drone can transport that just fine. And over here we've got 2 more ports. So all of those backed up heavy modular frames are going to the assembly director systems. And last but not least, we'll have 10 pressure conversion cubes headed to the pasta. And this is how we're going to get these products out of here and to the factories making the space elevator parts. And with the ones like this, it hasn't accepted any because it's not turned on, but that whole line is backed up. There's smart splitters set for the overflow, but when that gets turned on, then it'll start loading up. So the reason I'm doing it this way is I want the drone port to be full, so when I do set it up somewhere else in the world to come and get these, I'll have a nice buffer built up and I don't have to wait for it. Alright, time for my favorite part. So I'm going to do this in 2 stages, and I'm actually going to wait to start the timer to when I actually turn on the bulk of the factory. If it wasn't for making the video and wanting it to all come to life together, I would have turned this on a while ago and just put another sink inside the factory and had these sinking. It does take a little while to get over there, mainly because I like to use the right speed, and since we're only making 25, this is using Mark 1 belts all the way to the factory and inside. So there's definitely a lot of things you could do to speed this up. So instead, I'm just going to start the timer when the bulk of the factory is actually turning on. Feel free to let me know if you think that's misleading or whatnot, but the way I see it is I've already got these sinking right next to where they need to go, so the startup time for these things is super fast. But let's watch this come to life, and then we'll get everything else going. And now that the reinforced iron plates are pretty much here, let's go ahead and get this whole party started. And now that the crystal oscillators have made it this far, I can go ahead and go back downstairs, delete those sinks, and get the rubber and aluminum casings going. Might as well do that for the fused modular frames for the next step as well. There goes the first couple. Just gonna give it a couple more minutes. These should be able to stay on pretty quickly. And there we go. I now have 15 pressure conversion cubes being sent to the drone ports, and once those fill up, they'll just be sent to awesome sinks, ready for their last factories. Speaking of, the next project is going to be the assembly director systems at a rate of 20 per minute. So look forward to that. And thanks for watching.